I've had a request. What we've done so far is we've done the motor, and we were looking at extracting torques from that. Then we did the KTM 525. I appreciate one of the biggest, trickiest things in that assignment is about axes. Moving axes is rock. It's really difficult, and anybody who's been brave enough to take it on, you're welcome. There is some other learning aspects within that assignment which you might not have realised yet. I might discuss them at the end of this, just to throw in some Easter eggs, so to speak, just because it is quite an overwhelming assignment when you actually realise how much you're actually doing. It is quite a bit. Right, so today though, what I wanted to do is build up a basic suspension system. I was going to look at one that I actually found out on GrabCAD. It's not the most sophisticated one in the world. I'm actually recording that, it's really awkward. So if I go to Files, and this is on Teams, so I'm going to go on to Class Material, and what I'm going to do is now upload the where is it? I'm going to upload the suspension. Now it's a basic sus. I've just put it on there. So if I open that and I'm just going to upload it, then it gives us a basic suspension setup. Don't worry about construction just yet. I'm going to introduce this. So if you want to follow, Neil said if you want to follow me through. If you want to follow me on this process, you're more than welcome. But so I'll give you a minute. I'm just going to move across. This was, I think he's even give a JPEG. Right, yes he has. So let's just take a look. That is the basic suspension system. Now the way he done it is not the best. It's a little bit all over the place. It's a nice place for us to start looking at, and a nice spot for us to, get really into it, and it really explains the complication of setting something up like this. We can review everything throughout it, and anybody who's taken on this assignment by now, you should realise it's about position, and it's about knowing position. The thing is, with a dual suspension system like this, you don't know where everything's sitting. You don't know, well, I mean you do know, sorry, but everything's not sitting flat. Even though the components are relatively flat, everything's sitting at an angle, and the upper wishbone to lower wishbone is a little bit out of sync. These will be centralized, obviously, to allow for the spring damper to actually sit in position, and then this has a relation across it. Now what 90% of people have done so far is they've started off with the upper wishbone, and they're working along, coming down, trying to connect it at the end. Now, I've so much respect for you guys who are doing it. If you look at this one, I've got a new mouse, by the way, so that allows me to, I've got a button on it for zoom. It's mint. Anyway, you'll notice there that it's actually not sitting in line. This is why I'm going to use SolidWorks to allow me to have a look at alignment and take measurements. So it allows me to put in rigid transforms to create these connectors. In this particular model, you can't escape rigid transforms. You just can't do it, because here, if you look, this spring damper sits in midair under a hypothetical shaft, which comes through here and connects to the upper area. Now this is totally simplified, so I don't need to consider what components we're going to use, but there is a few components here that we might not even use at all. Right, so let's bring that out and let's begin. As ever, I'm just going to open up MATLAB, and what I've done is I've already got my folder ready. Now for me it's new too. Obviously name it something useful. So I'm going to right click, and then in fact I'll remove them for the minute. So it's removed, just so it's completion of the process that we go through. So go right click, go add to path. We're going to go selected folders and subfolders, and this now allows it to be a bit more flexible. And as we know, as I keep repeating, It allows us to take things around. We can move things around, which is great. So I'm going to go into new. I'm going to set up my basic world and get myself sorted out and ready to go. So I'll go simulate model. I'm going to go create model. And as ever, for this I need a world. So let's go solver. My God, that went well. So I was just trying to type it, and apparently it just decided it didn't want me to. I tell you, ever since I've had an argument with the company MATLAB's not been my friend. Right, so Simscape, utilities, and I want to bring in a solver configuration. So bring in a solver configuration. I'm going to go utilities, mechanism configuration. I'm going quick here just because we've done this so many times that I don't really need to explain exactly what I'm doing. So zoom it in, and I'm just going to configure these so I've got myself a nice starting point for my suspension. So I'm going to rotate that around as well and just put them into the normal configuration. We are going to play around with gravity, hence why I'm not going to drop that in as of yet. Now we need to decide essentially where we're going to start this from. For me, the big area here is going to be the main one. So this will be the upper arm that I'm going to focus on. I'm going to focus on the upper arm, get it into position, and then look at where it sits relative. But I'll open up MATLAB, I'll open up SolidWorks in just a second to show you the architecture so you can see the process with it. Right, in any start like this, because if you think about it, this is an ultimate revolute. It's always going to revolve around it. So I'm going to start with this point. So I'm going to go joints, revolute, drag and drop, rotate that round, and then connect. Oh, that didn't go so well. I didn't take it far enough, I think. There we go. So we're now we've now got our basics of the beginning. Just for this, I'm going to also save as. Let's call it. Suspension. Then we'll go save. Right, so I've been looking at this myself. It is really poorly done, is this model, but it's a great one for us to navigate around. Now the guy who did the model, the assembly was all messed up, it was all wrong, and this was just absolutely all over the shop. Totally all over the shop. Now what we need to know is where exactly we're going to start from. I don't want to save that, thank you. We need to know exactly where we're going to start from. Now, based on his original drawing, original-ish drawing, that is how its orientation should actually be. If you look there, he's got that in that orientation, and that's typical to an orientation that you get. So, but what we need to do is start positioning things and figuring out where all this is going to go. As I said, I want to start here. So, first things first, I'm going to choose exactly where I want this to be. This is going to open up some serious discussion. We need to decide where our very first starting point will actually come from. So we can either put a rigid transform in, make this centralized, and then do it. But before we do that, let's take a look. So what I'm going to do is, this is called the upper arm. So if anybody's if anybody is following me, that's where this is coming from. Oh, let me just get rid of that. I'm going to go to my bodies. Now I'm going to use solid. This is a custom folder, a custom file that I've made. It's basically, you know, the one that's in 2019A, the one that does the job for me. That is me customizing this. So I've stolen it from there and I've implemented it into 2019B. So that's all it is. It's not something that you guys don't have. That's my point. So I'm going to double click in, and then let's bring in the upper arm. So I'm going to go upper arm, F5 as ever, zoom to fit. Let's take a look at the orientations. Now this guy who done it, he started in really weird perspectives. So this will give you an idea of his skill set when it comes to CAD. So if you look here, oh my god, I'm making a pig's ear of that one. You look here, look at that. He's actually started at a random spot. I have no idea why anybody would start there. It's really, really odd to start there. But I think he's new to CAD. That would be my first guess. He's new to CAD because there is no relation to an origin at all there. So we know from that we're not going to use it. It's just pointless. So I'm going to drop R in just a second. What I want to do is I want to give myself a good positional perspective to start from. So what I'd like to do is I'm going to choose the center of this left side. So looking at the orientation, making sure it's pointing upwards to give me an idea if it's going to be constructed right. Today is purely about thinking about positional offsets. So I'm going to left click, I'm going to choose that, and I'm going to call this connector. You notice on the Z, Z's not right. What we actually want is we want Z to move in. I'd like Y to take its position. So what I'll do is say, let's have a look. Primary axis, I'll actually make it Y and Y. So what it's done now is it's converted Y to become my primary axis. So if I run it, it should rotate around it, but we'll find out. So I'm just going to drag that out, and I don't need that for the minute. I'm good. So I'm going to drag that out. I've left R on, so I need to turn that off. For my materials, I'm probably just going to use what's predefined, so a custom density. And I think so. In this case, I've left it in as, what would that be? Steel. So we'll go with steel, and then I'm going to connect it. This is just for me to take a look that everything's working. The other thing is, as well, is we need to edit gravity. At this point, still resides in Z. I actually want it to move in Y, so let's run it and let's just check. So let me bring that back. So my axis that I just added is incorrect. So I need to go back, need to go to my solid, and the frame that I've just added is not going to do it. Now if you remember, I was saying before, everything predominantly sits in Z. So that means I needed to say that my primary axis will be Z, and this is a complete flip, so I'm not happy with that. If I put it up to positive Z and negative Y, what it will do is flip it up, and it gives me a reference frame to allow it to flip round. So click apply, click OK, and then let's run that again. So that's what we're looking for. So Y is our gravity. Y is our gravity, and all it's doing is it's under no restriction, so it just continually will rotate around that axis, which is a great start. Now, setting these things up, as I've said, some have chosen to try to, in essence, what they've essentially done is try to draw along and then round. I personally, I actually don't find that useful. I find it really difficult to do it that way. I'm not saying it's wrong, so any of you who've been doing it, well done, because it's super tricky. but what I'm actually saying is getting it happily working as you want it to. So I'm going to come back to here. Now what I'm going to suggest is something that's a little bit more frustrating. In the model that I've got, if you look here, I've actually got a marker point on here. That is on the outer edge. What I could actually do is go back to my original declaration of where I've put that axis and choose it around this edge so I can match it. And what it will let me do is measure them distances. I've just chosen that center axis here just to show you that selection, you need to be cautious about what the selection is. So in essence, from the start, I've already made a mistake. I should point out I've actually not built this yet. So this is kind of like a joint experience. And the connector, where I've gone in here, it's selected here, but technically if I use this edge and then apply, sorry, 1 second. If I use this edge, then apply and hit save and then apply, now that axis sits there. So before I do anything, let's just check. Oops, that's just me rerunning. So rebuild and then run again. Right, so we're now matching what's on the CAD system. I did want to point out there was no need, there's no 100% need to use any CAD system at all. You can, interestingly, if you do have ANSYS running, or student ANSYS, you can actually put the step file into ANSYS and measure it from there. It doesn't matter where you measure it from. And someone told me yesterday that in Windows itself it has a file viewer, and you can measure on the file viewer, so you don't even need ANSYS. But I've not tried that yet, so I'll give you an update once I've tried it. Anyway, right, back to the point. So we know that that's our initial point here. What we need to try and do is put a positional offset onto the lower one. Now, where this point sits here, where this point sits here is where I need to figure out where it's going to go. Now, it's purely because if you look at where it sits, now I know everybody who's doing this assignment will be experiencing this. If you look at where it sits in on Y, up on in on X, sorry, up on Y, and then if you look at it from the lower side, it's actually moved down and here as well. So there is quite a big rigid transform across that. It is it's actually Cartesian. Now there is a super easy way of extracting all your values for a Cartesian axis. Every CAD system in the world, every viewer in the world allows you to do this. And if you've never seen this before, you're welcome. For those of you who are CAD savvy, you'll have seen this millions of times. It is such a useful tool, and it's the measure tool. So we know that our next axis is going to be here. How do we get that? Only way we can get that is a rigid, whoops, rid, come on you shizer. Oh, right, there we go. We're going to go a rigid transform. We know that we're going to use a rigid transform. We've got to use a rigid transform because these are floating in mid-air. There's no other way of giving it an orientation. So I'm going to snap that on. And I'm not actually going to add all these on yet. What I want to do is just look through the bodies. So I'm going to open up the Cartesian, bring it to Cartesian, set to millimeters, and then just leave that bad boy sitting on the side there. Now what I'm going to do is go measure. Now because points, I don't know if you've ever used CAD system yet, and when you actually select the geometry, sometimes it will give you from the surface and measure across it, and it gives you a totally wrong answer. It's, if there was a measurement of how frustrating that is. Anyway, so we go point to point. Now I've added these points. They're useful. Now look at that in its beauty. So we've got X sorry, we have X, we have Y, and we have Z. We've actually got, I know, right? We've actually got all the Cartesian positions in one single beautiful hit. If you are doing the engine, this is a beautiful way of extracting it straight outright. It makes life so much easier. It's frightening. Now, one thing you need to keep in mind is your y-axis here is not your y-axis in relative. If you remember, everything revolves around Z. So this green axis here is actually Z. And let's have a look. Z is Y, and X remains as it is. So what I'm going to do is I'm going to fill it in. So we're going to go X 16.75. We're going to go, this needs a little bit of jiggery poker in just a second, but I'll show you why. 16.75. We're going to go Y as 80.66. And then we're going to go Z as 15.22. So I'm going to click apply. And I'm going to close that just for a minute. What actually I want to do is I want to get up here. I want to bring this in. And we're going to do something which everybody frowns upon, but it's actually quite useful in this case. So if I scroll this to a similar position and we come here. Now if you look where that sits, I'm just trying to roughly match where I'm going. Something like that. If you look where that sits, I'm getting the same orientation. So what I'm looking for is a follower on the rigid transform that appears down here. Once that appears down there, exactly, you beat me to it. Exactly, you're absolutely bang on. That is exactly the jiggery pokery I was talking about. Or else you're right. So if I go on, let me just update the diagram. If I go on my rigid transform, then go to the follower, zoom it out, you're right. It is upside down. You're absolutely bang on. Now, because this interesting person had drawn the entire thing upside down, he'd messed it up from the start. Even these measurements are all over the shop. So what we need to do is we need to push in them minuses. Because you're right, absolutely right. So if I come back, I'll go into here and go rigid transforms. Now if we've got to think about where this is going. So I'm guessing if I push 80.66 into the negative, that should flip the lower side upside down. So let me just flip that back, and then I'm going to update the diagram. And if I go here, you see here, still in the same point. Yes, you're absolutely right, it does. It will give us initial point locations, but you're right, it will try to put out vectors, and that's the issue. That's why these points are added, because it will just put it, I mean in magnitude, sorry, and it will just put it out like that, and it makes things incredibly tricky. So what I'm trying to do is put them points in, and then it'll restrict it to give me something useful. So when we come on to 15.22, that again, going to go negative, and then apply, update the diagram. Boom. So now, if I start to look, because don't forget, X in this case is still going to be true, because upside down or not, it's still pushing along that axis. So now what we've got, if I flip it round, we've now got an axis that allows us to bring in the next component. So I'll just close that for the minute, and I'm going to go on to my next piece. So if I come in, and then come across, drag that in, and connect that in. And what I'll do is flip it up, bring it down, and then right click, drag it in, and connect the two. So I'll call this upper arm, and we will name this as according, so the lower arm. I'm going to try and keep this to the session time, but I make no guarantees at the minute. But as I said before, don't worry, this is recorded. So I'm going to go to step, and then going to go to arm. See, he's even named it arm. I'm not the biggest fan of the model, but it's a great one for what we want to do. So I brought in the arm. I'm using the same materials on the last one, that's why I copied it. If we go on the origins, right, you'll love this. So that's mine automatically. Now if you scroll up, that is the original guy's drawing. That tells me when he was actually constructing this model, he was actually doing it as an assembly. So it was trying to orientate the origins as it's going through, and yeah. I know. I was thinking the same. I was honestly going to message him when I when I found this. I was honestly going to message him and go, stop uploading crap. But I mean, for this example, it's actually quite good. But yes, it was a heathen thing. Right. So I'm going to go to connector. R is staying off. R is absolutely useless. Now, what I'd like to try and do is keep into consideration how we'd measured this. These are endpoints between each thing. So, if you look on here, my orientation sits like that. So that tells me that that is my target. So I'm going to just zoom into that area. I'm going to go selection. And I'm going to use that as my key point. Z's all over the place as ever, so I'm just going to reset these back so I can figure out where I want it to be. Now, because how this has been drawn, again, it's been drawn a little bit odd. Because of how this has been drawn, the orientation from the start was correct. So he'd actually drawn it this way. It's really strange how he's drawn it, but he's drawn it this way. Now we can use that to our advantage. The biggest pain in the arse here is going to be connecting these, but we can do it. We can do it. I'm going to save that, apply. So close that, and then come back to it. And now we're looking for this to be floating in midair, acting like our pendulum tap. Basically, we want two pendulums that are just floating around. So I'll run it. Ah! Das is not good. So let's have a think about where that's gone wrong. So that's coming from. Yeah, I totally agree. If I flip that x-axis, that's going to make it far better. So let's go back to the arm. I must admit, some of you are actually beating me to the punchline with all this. It is quite impressive. And then flip it in, go like that. No. Hey, don't apologise. I prefer it. It's rocking, because it just makes doing stuff like this so much better. Right, so I flip it up, and I flipped it. Now, if I run it again, I'm still getting this. Now I'm going to go back to the arm. I don't think I flipped it. Did I even apply that? So that was in X. Let's have a think. Ah, no, it's not. Oh, no. I think I got this one. Now, you're right for flipping. You're absolutely right. Now, what we can do is do something a little bit more sneaky. Let's go and make our primary axis negative Z. if we make it negative Z, it should flip the whole thing upside down and almost do like a mirrored effect, if you will. So I think that one's going to do it, and then if I'm wrong, we are going to go to Y, which will be very embarrassing. So come back, and then let's run it again. Now, so what I did there, I'll go back to it to show you. We've got that initial state position, so let's bring it back. Oh, that's not good. That's not good. No, don't like that. Because you see, I mean, once it runs into play, it's actually sitting in the right position, but it's actually upside down. So I think I'm going to have to call you Logan. It's such a weird, teaching online is so weird. I think you're right. I think we've got that orientation in Z, but perhaps what if we try and flip X, sorry, and try and get it to do that? The worst thing is now what it might do is it might reset us back completely. So let me just try and flipping that. That's better. Now I'm just going to run it again just to be sure. Right, so what we got now is I'll show you the configurations. Yeah. Well, if yeah, that's a good. Yeah, that's also a good one as well. Luckily this chat I think everybody can see, which is useful. That also works well as well, because I think what you've done there is the same as what I've done, and we've hang on a minute, got a visitor. I think what you've done there is you've done the same thing as what I've done, where we've actually achieved the same thing, if you will. So first things first, your configuration works definitely. So I'll show you my configuration, because I'll show you what I mean. If I go into here and I've made positive to negative as my reference, and I've gone negative to positive on the same axis as my reference, and that's essentially the same thing as what you've got there. Let's have a look. Yeah, it's what we've got, the same positional setup. And just out of curiosity, Logan, on your secondary axis you've got it still set as positive Z. Has that even worked, or is that a typo? Just wondering, because you've now got two references to the same axes. Ah, right, okay, yeah. So we're running on. Yeah, I was just double checking then. Yeah, I was just double checking. Yeah, so that's in fact that's what we've both done then. And now if I go back to my initial axis, if I go back to my model, we can just take a look. I only do this for anybody who's really struggling to get started. I do appreciate the frustration that this is. So let's take a look. If we look here, we've now got what appears to be in the right orientation, because obviously sometimes it can be incredibly frustrating to know if it's sitting in the right spot, and just to look at it will give you the position. So you look at them positions, you look at them positions, and we're looking pretty good. Pretty pleased with that, which is great. Now what he's tried to do is try to put it into an orientation of where it sits. I understand that. What we need to do is try to create that connection between them now. If there's going to be any difficulties, we need to know. Now luckily I think, unless he's done something else really stupid as well. Oh no, he's done something really stupid there too. If you look there, he was doing a really basic interface. Now let's just take a look at this component, this one in particular, because that's our next target, and then we're going to let it just fall and just fall through itself, just so we can see it and just be sure about how it's operating. So let's take a look around it. Now this is a direct slot. So as it's a direct slot, it doesn't make our life any easier, because if I go back to the original component setup, you'll notice there it actually does not touch anything at all. So this guy's clearly a total genius. Right, so I complain, but we can fix this. We can fix this dead easy. So first things first, let's bring in this component, and what we need is some revolutes on each joint, just so it has that freedom to move, and we're going to get that behavior that we're looking for. Just going to bring that down. We do need to revisit this bike, because if I just spin this round, we have the damper, mass damper interface here. Look at that, it's even not even. Well, at least it's a bit of fun. So we do need to revisit that, but anyway, right. So I'm going to come on to here, and I'm now going to add my further connections on. Now the question is here, how do we do it? Do we come from the center? Do we come from the endpoints? If I come onto here, and if I just look at how this is interfacing here, what we could do to make our lives easier is we could put a point on there, a point on there, we could measure the distance between, and then that will give us a measure for location. And then all we do is we're in the same position as we were a minute ago when we're trying to flip this into its correct orientation. So I think I'll do that. It works well. It's a good technique to be able to allow me to do it. So I'm just going to add a point. I'm going to make a point. And oh, you know, really, I'll flip onto here, put a point. Oops, that's me messing around. So I'll go point, bring in another point there, and click OK. Now we've got these two measurement positions here. We're going to use them because we've stayed on this side for its orientation. So we're going to build onto there and get to that end piece into position. So the end piece is called the hub. So well, it's hub 1. Oh, that's me. So I'm going to bring on my orientations to remind me which side I was deciding with, and as that was in that position when we were just looking on CAD, we're going to choose this endpoint here, and we'll call it hub connector or anything like that. You know what I mean? It's just something to give us a reference point. So I use that as selected, and we'll go hub connector. Oh, that's connect. So go hub connector, and again the orientation is in Z. So far that's good. I dread opening up this next one though. God knows how he's drawn that one. If it's just as bad as the rest of what is produced. This is the trouble with GrabCAD. I mean, a lot of people say, oh yeah, GrabCAD's really good, and it's good if you want some basic geometry. So if you're doing work with sensors or anything like that, you'll get a lot of people who've actually done a lot of these modeled sensors. I'm going to bring in my revolute joint because that's the relation, and then I'll borrow that in, and I'm going to double click. You'll notice you'll notice I didn't particularly mean to. I'm going to have to go back and yeah, agreed. It's Ace for barbarians, but it's just I'm not really meant to swear on this, but you know what I mean. It is just rubbish. It really is. I'm gonna go back to do this to make sure that when if any guys are gonna download this, that it'll work on theirs. So I'm gonna delete all these out afterwards. I've totally forgotten as I'm going through, which is schoolboy error, as I like to say. Oh, we got another visitor. I love how punctual everyone is. So we're on to here. I'm going to go update, and just making sure that everything's there. Really, we're starting to get connections, and this is the point now where I do want to just change this colour. And I don't do it to look bloody pretty. I do it so I can actually see relations across, and there is a direct difference between them. or else it can be a little bit frustrating. So I come back in, and we see there that the orientation of this, I often use something simple. So like this hole obviously sits beneath, and the hub, the connection, the axis, or whatever is, I mean, it'd be interesting to look at what it's called that, but it lets me know that that's the point I'm looking for. So if I come back and then spin this up, lets me know that it's actually that point that I'm going to add the connector to, and that allows me to then measure and change orientation. So if I just flip on my axes and just have a look where it's gone, connector, just as a reminder, these points will attach themselves to a frame to a surface number or an edge number, and it just means in here the edge number was there, so all I need to do is change it. So you see there, center of curve at 17. All I need to do is just change that. So I'm going to come in and I'm going to come down to here and then click apply. Z's into that particular axis, then save and apply, and then OK. So again, I'm going to save it and then bring that down, drag it up a little bit like that, and then I can connect in. There's a lot of connectors here, but I suppose we could rename them. So I'll come back, come on to here, sorry, come on to here, and then what we'll do is we will run it and let's see what happens. If I'm honest, I'm not surprised. So we have a choice now. I mean, the orientation of this, we know if I flip this up, let's flip it all the way up. So that's where it originally starts. We know that that is actually wrong. If this was going to flip it, if this was going to be in its right orientation, this axis, this axle would be pointing downwards. So we know that that's wrong. So we know it's actually the upper arm axis we need to flip round. So let's try the same thing that we did before. I'm going to go onto frames, onto here. Now if you remember when we were doing this before, we went, oh yeah, now this came out of here, so this is a tricky one. So if I go negative and then save and apply, I just want to see if it'll simply, I don't think that's going to fix it straight out right, but it's going to allow me to at least look. So let's just take a quick look at the model. Yeah, I'm going to spin that back up. Winner, winner. Okay, so that's good. That's good. Now I know you're probably thinking, well, it's not good because it's still a bit crap because it's missing on that point. All we're going to do now is push these apart with a rigid transform. Now, I don't know who's been using this, but I find this incredibly useful. Top of here, you've got standard views on 4. We can actually see orientations for it. We can see which way it's going, and I can just see to make sure that that's giving me a true representation. So I'm going to minimize that. I'm going to copy a rigid transform in. For this, I'm going to I'm going to leave that for the minute. I'm going to bring that across. I did say I wasn't going to do that from the start, where I wasn't going to bring in models and then do it. But it is what it is. So let's go back to SolidWorks. Now we're actually after this distance. And it is just that distance that we're really after, because these are reference points between the relation of two models. So let's go evaluate, measure, point to, come on you shizer, there we go. So that gives us 5.01. My God, that's very close. 5.01. And based on our model, it is in the z-axis, positive z-axis. So let's go back in, let's go to translation, and we don't want to move in x, we don't want to move in y. .01, and we'll click apply, and then we're just going to check now the model. Yeah, well, that's what I'm going to check in just a second, because I do think you're right. I'm just going to see if, because I wasn't sure about that myself a second ago. That's not right. So let me just go back to my declaration. I'm going to bring in minus, because the points come out of the right spot. It did come out of the right spot. Now that was minus from there, and that's just because of the orientation that I've been setting up. I'll show you in a second, Gareth, exactly. Oh, I've got a visitor. I'll show you in a second, Gareth, where we'd fix that, because mine was as well. It's about the orientation, it's about the configuration where I'd set that up, but I'll show you that in just a second. I just want to check the points. Now, it did take its initial position from just the geometry. If I come from the right side, oh, it's a really weird way it's drawn, is this. I will shut up about it at some point. Now, so let's go 0.4. Whoops, measuring things in. So there's 0.3, 0.5. Yeah, they are in line. They're all in line. So it's just a double check, because as you said, Logan, I totally agree. I just wasn't sure, so just had to double check. Right, so just addressing on the x-axis. Oh, good shout, good shout. Let's have a look. So the best way we can check this is go here to here. Oh, that's not the right bloody one for a start. There we go, 0.4 and 5. So what we'll do is we'll check it to see how it returns it. Now you look there, for my absolutes. Now I've got the distance, the absolute distance here. If you look there, it's suggesting on the X, the Y and the Z, you've just got one single offsetted axis. So it suggests that they are sitting. Is it? Did we put it on? Oh, shh. Did I put it on the outer edge? Let me just bring it in. Did I put that on the outer edge? No, I didn't. We're on the inner edge. I've got it on the inner edge here. I can see your point though. Yeah. It may have been because when I added it in, all I did is rushing as ever. I've come in, clicked, and then clicked apply. And it looked like I may have gone on the outside, but I didn't. I went on the inside. Gareth, with my flip, you see this configuration here. This was to do with me trying to flip things round, and I changed my Z to minus and my Y to minus as well. Okay, let's have a look. So 0.5 on the inner edge. Whoops. So let's just have a look into here. 0.5. No, 0.5 is on the inner edge. It's there. I know. Yeah, I know, yeah, I know exactly what you're saying. The worst thing is as well is because this model's been created so poorly. When you're actually looking at it and looking at what I've done to what you've done, you kind of go, "Is that right?" Because if you look where it's actually sitting, it's a little bit out, and even the mount. So you look at the mount, look at the mount. It's like what? So yeah, I'm so I so know what you mean. Right, I'm gonna come back, and now we should be getting close to be able to construct all these together. We now know that that sits in the right spot, so I'll apply, click OK on that, and looking at this is a perspective, update, and then run again, and now it's flipping around like I want it to, and now what I do is try and connect that to the upper one, and then it's going to have a little bit of a complaint at first, because we need to make sure that as it connects everything correctly. Now, because we've been measuring systematically piece by piece, we might be able to do this in one hit. I hope we can, because whoops, because when we're generating this, it can be such a difficulty. So staying on the same perspective, staying on the same procedure, I'm staying on this right side of the configuration. I'm going to add 2 more points, so I'm going to go point, so I'm going to go outer edge. I'm going to go outer edge on the upper arm, and I'm going to go inner edge on the hub, which is there, and then apply. It's because I've still got the other point selected, so I'm going to go inner edge on the upper, on the hub there. So then we've got the same configuration that we just had. I'm just going to, just because I was rushing there, I do appreciate that. So I'm just going to show you that I'm on the outer edge of the upper arm and the inner edge on the hub. So what we're going to do is do the same thing again, just recreate that process. So I'm going to come onto my hub. I always turn the orientations on just to give me an idea of where everything's sitting. So I'm going to go add another connector. I'm going to base it on selection. I'm going to go in the inside upper edge of the hub, so then I'm on the same orientation. Then I'm going to call it the upper connector. Use that selection. Use selection as normal, and to allow me to just emulate exactly what I've just done, I'm not going to do anything yet. I just want to go to this connector. I've got -Z, -Y. So I'm going to do the same thing here, so I've got the same configuration. So I'll go -Z, -Y. So then these two are emulating each other. It does make life a lot easier for construction, because then you've just got an idea where everything's sitting. So I'm going to revolve that and just bring that up. Oh, like tidy boxes, just saying. It's a little bit don't like that, but it's working, which is important. So I'm just going to revolve that, bring that into there, and what I'm actually trying to do is just emulate the configuration. So the upper arm would sit there, the lower arm would sit there, so it's almost like a positional flowchart straight away when you're seeing it, and then that will tell you that that is me choosing this as my starting point as an axis. And hopefully now we're getting to a position where we should be able to start running this. So we went on the outer edge here, so I'm going to just make that big, come onto here, and I'm going to add in, I'm going to turn on my axes, and I went on the outer edge. So I've on the outer edge, click OK. So we're going to go, I'm just calling it outer connector. Call it anything you want really, but I'm going out to connector. And then minus Y. And I think that matches our other configuration. So when they snap together, it's going to be a bit closer. Because obviously if I went minus Y and minus there, that's what we get. But I don't want it to do that, so I want it to do that. I'm just going to have a go. It might not work. Once we start to connect these up, it's really going to complain. It's MATLAB, it's what it does. The other thing is here is we really need to add our rigid transform to connect these frames up. So I'm going to copy that in. I'm going to bring it into here. And let's go back here. Let's go evaluate, measure this point. Oops, and this point. Distance 1.91. Okay, so let's do that. Come back into translation, and we're going to go 1.91. That should align these up. should align these up. So let's have a look. Update diagram. Oh, damn it. So what I'm going to do is I'm going to delete this one out because I want to see if the orientation is correct when I have it like this. So that's what's going on with it. It doesn't have it in the correct orientation from the start, so we need to flip that round. Anybody's been doing this assignment, you've probably come across this millions and millions of times so far. If you've not, congratulations. It is you're lucky it's not happened. So I'm going to open connector. Let me just have a look again. We're going to minus Z minus Y. We will map the same thing. So orientation, outer connector, minus Z minus Y. Then update. Much better. I'm going to try and connect these up. See what it does. So there is now a violation. Damn it, we need to figure out where this is coming from, which is a shizer. So I'll come back, bring it into here. I'm just going to look and see if we can figure out where this is coming from. So there is a configuration here that I have not considered. Okay, so let's bring that back. This is similar to the piston. What we need to know is where that follower is and where the upper connector is. So if I go upper connector, well, I could still we'll call that hub because I'm going to get that very confused otherwise. Go hub, update that again. So now we've got so update, still down as arm, brilliant. So we'll go here, and what we're looking for is the second frame in this case. That annoys me, doesn't update the names. So looking for the second frame, and then we're going to so look, connector to rigid transform, and then we're going on that state there. So if I go to my rigid transform 2, what we want to match is here to here, and that is the kicker, how we bring them together. We could try rotating it. but we don't know it's at 90 degrees. So let's have a look. I could try making this connector naturally move across to here. So let's delete that and see if let's delete that and see if we can fix that. Take that round. These are the tricky bits here. This is where the frustration really lies. So let's go to frame 2, frame 1. There we go. So bring that back. So that's not going to do it. So we've got base to follower. Bring that out. What we need to do is offer more alignments. That's what's causing the problems. So look, lower arm in Z. Yeah, rigid. Yeah, you're right. That's exactly what I'm thinking. Because the frames at the minute are too far. They are just too far apart. So what we're going to do is consider these rigid transforms that have been added, and also how things have been connected. So they need to. This in essence needs to rotate. Because arguably, because it needs to translate itself across and down to here. That's the point. So these edges need to meet each other, because when I snap it together, it pulls them apart. And where this frame sits, where this frame sits, and this frame sits, it's incorrect. So what we need to do is figure out a way to get these two to talk to each other. So let's have a look. So frame 2 sits here, which is on the edge. We've then got frame here, which will keep them aligned. So this now, these two should remain aligned, because that's what we measured, if you will. So I'll just come from, I need to come from a more perspective that I can see. It's like here, or maybe more like here, or here. That's better, right. So if we look here, we've got frame 2, and then if we then look here to the follower, these two remain aligned, which is good. However, frame 1 to frame 2, you can see there, Z-axis resides, but they're a mirror of each other. If you look, they don't meet at the end. So my first initial thought would be, should we not try and revolve the axes? I don't want to edit this yet, so what I'll do is I'm just going to connect this up here, and I'm actually going to remove that. So let me run that again. And we've got rigid transform 2, so a rigid transform 2 now sits there, so the follower sits there, now the base sits there. Then if we look at where our Revolute follower, so let's have a look what that one is, Revolute joint 3, if we look at the follower and the base, the follower and the base, I am going to try revolving this, just spin that up, let's have a look. So revolving Z. That's what I was thinking. So let's do that. Let's bring that in. Let's try going. I'm going to drop that Cartesian or else it's going to throw massive issues all over the place. I'm going to go standard axis. As Damien suggested, in Z. We'll go 90 degrees. And just to give it that same orientation. So I'll now connect that to the follower, do an update, and I just want to see, and then in fact I'll connect that as well and see if we can get a bit more relation. Now, that's only because it's backwards. So what if we go positive? Beat me to it, like it. So if we go back and then go positive, so we've still got violations, but we are nearly there. If you look there, we've still got violations. Right. So now, where are we going wrong? So look. So something not playing ball. Just want to run that again. Got a bit of an indicator there, would be so much better. So I'm going to go rigid 3, bring that back, go base, follower. So there is a frame not connecting correctly. Somewhere there is a frame. So, okay, we're going to have to trace this along. Oh yeah, you mean to isolate exactly where the frames... Yeah, I'll try that actually, it's not a bad shout. So if I comment that out for a minute, comment that out, let's try that. So we did actually have a motion there. So that runs as you'd imagine it. So we had a motion there. So if I just bring in just my lower connection points here and then uncomment them, update the model. Now I think Logan was moving towards this earlier. Is it the upper arm connecting here, do you think? Let's have a look. So it makes me wonder if that rigid transform's doing its job. So going to minus 5.01. If I just uncomment that, violates in, but so why would that? So we have that there. So why would that not be playing ball? So let's just have a look. Model assembly for piston violation resolves in issues simulated. So the model, okay. Then we can actually turn that off, but I still want to know why that's not playing ball as it should. It means there's a value somewhere that's out. So let's just go back to the original model. We've taken point to point. We've taken more points to points here, so we've translated across. Yeah, I'm thinking the same. I think if somewhere there is a Cartesian not playing ball as it should have done. Makes me wonder if this Cartesian is a little bit out, because that was the main Cartesian that we applied. So let's just measure that once more. So Z positional axis there, but I just want to compare these Cartesians to what I'm getting. Well, I just want to compare these value sets to what I've got in. So I'm just going to go in on my rigid transform and just compare that again. So we've gone 16.75, 80.6. Oh yeah, 80.66. Looking at that distance there, 80.66 and 15.22. So it is moving on the correct axis for that orientation. Let's have a look. So then we move on to the next phase on this measurement between the outer to the point here. Whoa, come on, you swine. And there to there. Registers 0 for each positional axis. So we are moving on that correct perspective, and then we are then moving to the next point up here. So just clear that, and then come into these points here and here. 1.91. This is a tricky one. This is a tricky one. So, what about? Because that's what we positioned. We positioned there to there with the rigid transform, then created Z along this axis. Okay, let's have a look at the orientations. Are the orientations mapping correctly? Because we moved quite a few axes, if you remember. So we're going to have to check the axes. So I'll go from top, right from the top, and all the way up here. And then we'll go lower arm to frame, Z's there, and Z's there. That was both the axes between, which is fine. Then we've gone frame here to Z, is correct, what we were doing. Then we've gone Z here. So upper arm, Z, then Z. We stayed with the same orientation. Oh, hang on. So that's my Z. And then let's just check the lower arm. Oh yeah. So that's what snapped it into position. Then we go lower arm to Z down here. So they're now active. So that's correct as well. So there's one thing here that's not playing bloody ball. Okay. So that's my flip. Translation there. My flip there. Still something not playing ball there. So there to there. Just going to bring out one section and just take a look. See, because it moves like that, that's what makes me think there is something there that I should have considered. Have a look at this in between itself. Bring that in again. Yeah, there is one connector there that's missing somewhere. Give me 2 seconds. I'm just gonna see if I can just actually look at where this is coming from and figure out if I can just shut this off for a second. Because this will give us a quicker answer rather than going backwards and forwards. definitely not happy there. To figure out exactly where this is coming from. Okay. Connection points in the reference here to here. Oh. Everybody keeps messaging. They all message me now, which is difficult. Right. So, if you look at that there, I think that's where this is coming from. Look at the joint, Revolute joint 3, in my case B, there and there. We have an orientation there, and I think we need to try and align these. We need to try and align the axis planes. So I've not done a lot with axis alignments, so I'm just gonna have a quick play around with this, because we're gonna go alignment axes, and we're gonna try and align all X, Y's to base the followers and Z to base the follower. I'm gonna apply. This might throw a big hissy fit, but I just want to see if it's gonna try and resolve this problem for us. No, what I actually want to do is I want to align. I want to align Z to Y. Let's just see if I can fix that. Yeah, I'll go back to standards. I'm making a pig's ear of that one, I think. Right, so it's got me at a bit of a halt there for a second. Translation there. So that's our axis configuration. This might be to be concluded at this rate, because that one has just caught me off. So let's just delete that for a second completely. Then let's just update that. It is this rigid transform. Yeah, I think that's what it is, Logan. I think that's the same as well. It's that ever slight rotation, and that rotation is in essence, I think that's where it's coming from. So the lower arm on the Revolute joint. So between these, they are actually slightly out, and I think that's where that's coming from. I'm gonna have to think I can come up with a way to fix that, because I think that is where that's where it's at. Yeah, I think it's a rigid transform, and I think because that rigid transform is just giving us that dicky behaviour, I think that's where it's coming from. Because as Logan said as well, I'm going to keep calling you Logan, as Logan said as well. I think it comes from this slight axis rotation here. So I don't want to keep using cab because I appreciate that not everybody's familiar with using it. So I want us to try and figure this out from here, and that's tricky, to be honest. It's very tricky. So by basic rigid transforms, we need to try and figure out where that's coming from. And on the lower arm, it's that rotation there, that distance there. So I mean, I could construct this on CAD, but I don't think that's going to solve us directly to fixing that. There will be something there. This is a real tricky one. I like this. So 5.01. So that's where that should sit to there, and then we ran along here doing a similar thing like we did on the piston. So we've come this way. Oh, hang on. So that orientation was there, but I wonder if that needs to sit there, and then we rotate the axes in that way. Because then, oh wait a minute though, hang on, no, that might be wrong. That is wrong. Yeah, but if I comment these out here, it will just lose connection, won't it? So if I comment them out and then run it, it will just lose connection. So the relation's there, and like Damien said, and like Logan said, yeah, you're right, and like Logan said, I think we're coming from that transform. I think that transform is making things difficult for us. So what can we do? So let's bring this back, because if we put in that state, that is where the lower arm actually sits and starts from. So, oh, saying that, no, oh, hang on a minute, no, what if I delete them out just for a second, bring in that revolute joint, uncomment that, yeah, but what if, so if I run it, but then what if I take another rigid transform and flip it round? So the lower arm y-axis has to go in the opposite direction from the upper arm. Oh right, yes, you're saying here, Damien, on the connector here. Right, yes, that's a good shout. Let's just try that. So the lower arm axis. So we're saying the connector, aren't we, on the main connector here? Oh. Let's have a look. So the lower axis connector, and then if I push that in the Y. for me. Yeah, I need to flip that round. So let me just, I'll put that back. I'm going connector. And I'm going to flip that back. Just go positive. Go positive. Negative, like that. Okay, save, save, save. We should come back to that. Oh, that went horribly wrong for me. Have I gone on different axes there? Oh, I have gone different axes, haven't I? Let's bring that back. I think we went negative there, didn't we? I've totally ballsed up my lower arm here. 1 second, I need to just reconfigure that again. Moving that back. And let's just, that's better. Right, so I can just put this back together, that's all. Let me just do that again. Why am I going all balls up there? Let's have a look. Connector. Back on negative. Going batshit crazy at the minute. We should comment these out. Bring that in. Ah, that's why. I'm just going to delete that out. Delete that out. I'm just wanting to put these things back in position because I've just messed around and. I've moved things around and I've got myself all over the bloody shop here, so I'm just going to quickly get myself back into the same orientation that I was in before. At least then I'm on the right road of where I need to be. So I'll click on there, then click apply, then update. Right, that's it. Okay, yeah, that's it. So then if I bring that in, it should go batshit crazy as it has been doing so far. Then into there. Right, so yeah, it's rotating rigid transforms and pushing these things around is very, very confusing. As you can tell, I'm getting myself confused here just doing it. Yeah, I'm pretty much starting to think we need to revisit this again. I'm going to figure out where this is coming from. I'm not going to stop yet at all. It's just I don't want to like keep you guys on here forever because it's a fascinating problem. I love this type of stuff when we're just trying to trace back as to where it's going wrong. Right, so if I just move that out there, comment that out, and then what I will do is, sorry, I didn't mean to actually copy that. Let me just double click into there. I'm going to change this. I'm actually probably going to turn this off for the minute. Or am I? Or am I? No. Bring that up. And what I'll do is bring this out, bring that to there, and bring that back in, and then uncomment that, and then with this I've got a bit of a way for moving around axes. And I think you're right, Damien, think these axes need to reside in the same orientation as each other. So let's just check these again. So I go upper arm, and I've got lower arm. So if I go to my frame 2 or frame 1, frame 1 sits there, and then if we relate to the world sits there. So frame 2, frame 1. That's where the violation is. We've got these rotations. It's where it's been pulled into place. So where have we got frame? Let's have a look. Upper arm on frame 1. So we've got that there, and what we want to try and do is keep all these aligned. So I'm going to pull that out. The only reason I'm doing it is I want the system to align all its axes to what's moving. So even though it's been moved, I want it to try and align it. Not like that. I'll just pull that out again. Well, in fact, I'll just pull it out, delete that off, and run it in. What I'm actually wanting it to do is to align all axes in the right orientation. So we've got world, and what we want is we want Y and X pairs to be aligned from the world. So let's have a look on my pairing. So pair 1, I want to pair not X and Y, I actually want to pair X and X to the base and the follower. I want to pair Y and Y to the base and the follower. And what I'm trying to do is just incorporate that slight rotation, that angular displacement with it, and see what it does. Still violation. That is very frustrating. And I wonder if it's worth trying to do the same thing down here to try and align these in. So I'm going to copy that in, and then we'll bring that down, and I'm trying to get them to align themselves to any violation that's been there. So still not happy with that. It's not good at all. So let's bring that over. Tidy boxes, you know how it is. Okay, so I'm going to do that here, and this time pair so it's pair X to, so I'm going to try and now pair Z to the follower and Z to the base, and I'm going to try, and I'll probably just try and stay with Y there. I'm just trying to get them to pair each other up so that if there's any orientation, it will try and stay with it. I don't know if this is really going to work, but we'll try. No, that's not working neither. Scheiße. Okay. That has gone horribly wrong there. Okay, so let's come back to it. You know what? It's what we're going to do. So I'm going to suppress it. Oh my god. No, I don't want to suppress everything in sight, you stupid system. If I come from the right plane, I'm just going to look at that right plane and look at that. Now, I just want to see if this remains flat. Because what we've got, looking at that, even that's looking a bit dodgy to me. Yeah, I do need to reconstruct that. I'll reconstruct that and find exactly where them orientations are coming from, because I'm not convinced at the minute. I mean, based on his original drawing, we look from the right plane, what we're essentially doing is trying to recreate exactly what we're getting there. And yeah, that is yeah, there's something not right there. Look at that. Something definitely not right there. And let's take a further look then. There's something missing there, and that is going to bug me, stupid. No, in this case, Gareth, what we're essentially the biggest trick in this is actually getting this to construct. The actuation process we still need to add. Once this actually moves and we get it and it flows and it they connect correctly, then that's pretty much nailed it. Actually, adding the further things to this, all we need to do is add a spring damper. Now we're going to add a spring damper into there, but the issue is at the minute is because we've got this violation. Oh my god, look at that. Even the hole's actually not in the centre. Because we've got this violation, what it's doing is it's stopping us from being able to progress on that, and that's where the biggest issue is with this. I mean, arguably it's to do with the lines that we've drawn. Now there is somewhere on here that's not meeting correctly, and best thing you can do now is come down and go connections there to there. So that should still operate around its axis because it's a relation between multiple points. Onto there. Onto there. Onto there. There's something there. Oh, hang on. Is that an orientation down here? Let's have a look down here. Well, the Z is still joint 3. Joint 3. Let me have a look. Joint 3. Onto joint 3. This. Oh yeah. Yeah, that's a suspicious one if I ever saw one. Okay, so I'm going to go on to joint 3. Joint 3. And I'm suspecting that the actuator is going to be set to automatically compute the motion. Leave that in there. And yeah, leave that there. Model configuration. Because if I suppress joint 3, unless we change its orientation, because then the base commands its position, then but the orientation shouldn't really affect it. I can change its orientation. Let's flip that round. Yeah, it still resides in its same set. Because then that would move to there. So world frame should start, yeah, the world frame starts at the same position as where the first revolute sits. Yeah. In essence, yeah, because if you think about it, you're right. If when we rotated it in 90 degrees, it may be looking for a lot less. So, oh, that's my translation. I only like pause for a second then. Yeah, when we moved in that 90 degrees, I'm just going back to the same configuration as you guys. That's all. When we moved in 90 degrees, it may be looking for a lot less, more something like 85. But even then, that's going to be me just guessing. So if I, oh, wrong button. If I go there, I think this is where I'm going to have to really measure what that distance is. I think I'm going to have to measure what that particular distance is. And then this is where the measurement thing's really, really frustrating, because it'd be useful to know what that is. Because this is me now just plugging to guess. But even then, if you consider the other orientations here, go there to there. Yeah, okay. So if I got 0 degrees, I should just flip it around completely. Yeah. It is purely this rotation when we're bringing it in like that. I think what I really need to do is I am going to have to take this off, I think, and try and solve where this is coming from, because I would like to get this one solved, because it's a good one, and the frustration that a lot will have will be finding this on that assignment, and I want to make sure that I can answer that particular question. There is still a few things that we need to do to add to it. So for example, I need to add a center axis point here to connect to here, and that is where the joint damper is going to come in. But I do actually really want to solve this. So this may be to be continued, purely because at this point I can't figure out where that's coming from. I may even reconstruct this in SolidWorks, just see if I can measure what that distance has been. Based on what? Because I measured that Cartesian back in. Let's just have another look. So that's me measuring the Cartesian. Could be though, could be. I mean, that would make sense. If there was something going to be messing with it, it would be the Cartesian, which was not allowing it to, it would cause that violation. Yeah, you mean like a rotate? tell you what, let's try that. At this point, because it's gone, because it's breaking down, we can try that. So, one question from Damien, who, if nobody saw it, is what if there is an extra thing from the Cartesian that we've not added? So what I've done there is just tried to, oh no, in fact, if I come to the right plane and then just draw, I'm just going to draw a line from my center axis here straight up to here, and then I will draw my particular point here to here to give me a question of to that degree. And the trouble is, it won't be the same because of how this has been constructed in there. That's got it in at 13.92 degrees coming from the lower. Now when we were rotating, we could try going 13.92 around the Z. Yeah, that's what I mean. It's how I've constructed it. And if I reconstruct this on SolidWorks, it will allow me that a little better. Yeah, the violation still sits and resides. So if I just come onto that, onto there, somewhere. Yeah. This is really tricky. Really tricky. I quite like this one. If I put it onto there, push it to the negative. Yeah, I am. I'm going to revisit this. I'm going to need to. Because there will be something here that I'm just slightly missing, and I did think that we would be able to solve that one relatively quickly. At the bottom, because the bottom actually doesn't have any rotations in it, so we've only got positional sets here, and looking at where that sits, there is, because that's the one thing I didn't consider. If you think about it, I didn't consider positional offsets here, and what the system's looking for is that finishing orientation. So if I go to here, and then didn't consider any rotations there at all. So you look at them from there to there, that then gives us 5.75. So we've got 5.75 and we've got that there, and it makes you wonder whether what we essentially need to do is keep that Z rotation, because we needed to move the body round, but we also need to give it that restraint, that positional offset to tell it where it's going to be. So let's just, in fact, we got plenty of, well, we haven't got plenty of time, but oh, you're saying okay, I can go with that. I'll go with that. So if I go 77, what you mean on the Z? I think that's a good shout, actually. Yeah, I mean, to be fair though, Damon, it was a good idea. It was a good idea. But we've got this rotation, and I think it needs to be tidied up. So I'm going back to, that's base to follower, so that's me pushing it that way. Let's just flip that round, because then if I go follow base to follow in this direction, it will totally knack her up. Let me go. Okay. So I'm just going to flip back to 90 because then that still stays in its remit. What I'm also going to do here is I'm now going to try and rotate on this position here based on what I've just measured from SolidWorks. This upper one was 5.75. The trouble is that we're still going to end up in a similar sort of scenario here. 5.75, because it still needs to be aligned. That's the point, that they're all always needing to be aligned. 5.75, and we'll go 13.92. Wow, that's miles out. Let's go to here, bring that to negative and apply. It's just, and then yeah, that's interesting. That's miles out. So that's a measurement I took from the CAD system itself, and that was miles out. So that's interesting. What I think I'm going to do is I'm going to repair this. I need to figure out what's gone wrong there. Apologies that we didn't solve that out right straight away. I am going to revisit this. I'm going to have to revisit this tomorrow. Gives me some time to actually review what's gone wrong there, because something's clearly gone wrong, and I need to figure out where that's gone and what happened there. Because there'll be something that I'm just missing there, and that's what's frustrating the most, really. There will be something on. That's what I really want to. I really do need to take a look at. Because I mean, if I remove that completely. Oh, hang on. So if I use a world frame, will that not just locate it? No. I'm just trying to cheat. Yeah, just trying to cheat. Actually, and then if I just remove that, yeah, no. Bring that back. Yeah, it should, Gareth, you're right, it should. The connections across it should be exactly the same. And oh shit, yeah, it should. I mean, oh damn, yeah, it should. Yeah, it should, you're right. So starting positions, initial starting position. Yeah, it should. So if I go 5.75, they're violating the arms are violating each other. The joints are violating each other. We've done this before, and this was an initial problem that I'd had before, and that's why it was totally out, because I'm running on the. Okay, let's just try on this as an initial starting state position. They're trying to start in a different spot. Oh yeah, they are. They're trying to start in a different spot, and that's what's causing this. And that's where the initial start position will just give us an initial idea. I'm saying that we might run this now and might go nope, but I think that's what it is, because all our positional states are sitting right. We're in an initial. Everything runs as it should, but so hybridism. 5.75 is actually no, but still the violation. This is this sounds really nerdy, but this is actually a really interesting problem. I like this. This is quite good. So what if I push that into the negative, and then hang on. Oh, negative. I think this is just going to come back to Damien's comment, right? I think because that gives us the position offset, like the model gives us. So that does give us that initial starting position. Yeah. But what I think we got, is coming back to Damien's comment earlier. I think what we got is, if we check on this, you look at that alignment, then we check on this, you look at that alignment, they align to each other correctly. They are in the same orientation, right? Now, because this sits on the world, this is the center point of where it will revolve around. And I think Damien has a point when, if I click onto here, you look at the orientation onto this X and Y. No, that shouldn't do it neither. Oh, interesting. Onto here. Because they do meet. Because they should rotate around these. Like these just refer to the frames moving. Yeah. If you remember on the piston, when we were revolving the axes, what we were doing is we were flipping it to get them all to meet at the end. And that's why on the other, if you remember when we did this before, what I'd like to do for the minute is just, I'm not going to have any initial starting positions. I'm going to reset all my starting positions. And we're actually just after that, so I'm going to save that. We're actually just after the alignments between the two, and I still think here is my rigid transform 2, and I still actually think this is one of the initial problems I'm getting with it. So I'm just going to bring that in, and I'm going to get rid of that. Rigid transform 2, I need that to connect with base and follower of the Revolute joint. Revolute joint 3, and this is the same thing that we were doing. So if I go follower there, we've got the Revolute joint there, and then I'm needing these to be aligned with rigid transform 2, and that is the base of the rigid transform 2, which sits there. So hang on a second. So if I just hold that line there and then go Revolute joint 3 to follower, so it sits there. We do transform base. Oh shit! Look at that. Down. Follower. So look at the X. X moves downwards. Then look at the follower to Revolute joint. X moves along. Oh. These orientations are wrong. So, yeah, slowly but surely. So, if them orientations are wrong, so let's go back there. I need to just be really clear about this. Really, I want X to move out of the hub. So if I go to base of the rigid transform 2, X doesn't move out of the hub. I'm going to try with the upper arm. All we were doing is we were doing Cartesian, if you remember, moving stuff around. So I wonder if that's where I'm coming from. Oh, look at that. Look at that. Really, what I want is I want X to move this way. I want Y to go downwards to match to the other revolute joint. And then I need to snap it together with the transform. And I wonder if that's what's causing us the problem. So my primary axis, I've gone to Y, negative Y. I'm just going to change that back to Z, so I can just think about where I'm moving here. I want X to be where Z's going to be, so I'm going to go back to Y. And then I'm going to make, in fact, hang on a second, I'll just put that back to Z a second. And I'm going to make Y my primary axis. Oh, sorry, I'm going to make Y my primary axis. I'm going to move Z to where Y is. Oh, fucking hell, I'm confusing myself here. Definitely confusing myself here. So then I'm going to put that into Y. Nope, nope, still not quite right. Down to positive. I want that to be on X. I want that to be on Y. Right, start that again. Let's zoom that in a bit. Right, so I want X to push outwards. Right, so if I want X to push outwards, if I make, is it going to complain? If I save that, this is going to have a bit of a bitch fest now. It's going to not be happy with me, so let me just try that again. Because in essence, what I'm getting is, you remember when we were snapping it in before and it was flipping all over the place? I think we're getting the same thing, because the axes are in the wrong spot. It's trying to take the hub into in a wrong spot and then the other into a wrong spot. But the issue is we used that rigid transform, if you remember. Let's have a look. Civil violation. And so that's now done away with the Z-axis rotation. The worst thing is we could be possibly back to the starting point here, because I've done away with that Z-axis rotation, but it still doesn't solve the next violation on this. So these two now talk to each other correctly. So I'll just remove that out and rebuild again. I mean, it makes me wonder whether, in this case, I need to actually revolve the axis, this axis, 90 degrees in Z, to see if I can get that to connect. So bring that back, coming from the upper arm. So let me just delete that. Rotate that. So I'm going to go standard axis 90 degrees, and what I can see is negative Z. What I want to do is try and shove this body round. That's what I'm trying to do. Base to follower. Bring that in. So that did not do what I was expecting. So if I go rigid transform 2 to base, okay, so what think I'm doing there is I'm actually going the wrong way around. Turn that up, bring that up, connect that to there, and then run. So hub should be rotating to there, bring that to there, and then connect. Positive X. Yeah, that is going all over the shop there. Absolutely all over the shop. I do think I really need to fix this. Yeah, I know. This is the world's shittest model. This is massively the world's shittest model. It's let's have a look then. That's why it runs on the Cartesian. That's why it runs when we disable the Cartesian. You know what this might be? This might be coming from. We've presumed that this is symmetrical. We've presumed that this. We've presumed that that's symmetrical, and if it's not symmetrical, it means that I have actually may have been measuring from this side, not this side. Yeah, this is a really shit model. Let's just have a look at this model. I'm starting to see, well, I thought a nice simple model just to try and get it. I don't know, it's looking quite symmetrical. Let's have a look. So we'll take a, let's just take a few axes points. Yeah, but what's your point? Are you saying that there's another area of this that isn't symmetrical? Ah, okay. Let's take a look. It's a good shout. It's a good shout. No, but then, if that's the case, because we've got this isn't symmetrical. I mean, look at this. This is crazy. But if that's the case, when we've been constructing, we should have built what we can see here, and it should. Yeah. I think you're right. Though. I do think that this model. Look at this. Yeah, because that's really measured correctly. Okay, let's just take a look on the upper then. It's this upper one I'm suspicious with. It looks like it's been done correctly, but I'm just not 100% convinced with it. Let's get on to here. Oh shit. So let's just check. Go here to here. Yeah. Okay, so then midpoints are symmetrical. However, holy shit. Oh, damn. isn't symmetrical. That's... Oh, damn. However, there is one catch with this which won't cheer you up much. If I go in here and then on here, we go okay, sweet. Yeah, I know exactly what you mean, Gareth. I was thinking the same thing. Oh, you go, oh yeah, look at that, 23 millimeters. Okay, and then we take it from the center and we go 10.86. And then if we go from here to here, it's 2 mil. It's 2 mil. Well, I mean, near as bloody damn it. Oh my god. Oh my god. Oh my god. Right, so that's good, but there is still a problem. So good call, Logan, spotted it, but there's still a problem. It actually doesn't answer the same problem that we're having. Right, so think of it like this. We know that this orientation is... So if I just come from the top, I just want to look down and just see if... God, I could have chosen a better model than this. Oh my god. We took this point from the hub, yes. So this is a distance. Then we took this point from the hub, fixed at a distance. We used this distance as a Cartesian relation. So this is where our drawing sits. Our frames sit. So the problem is it doesn't matter. If you think about it, it actually doesn't matter. It doesn't matter that they aren't symmetrical, as embarrassing as that is, because that is embarrassing. Jesus, that's embarrassing. But the frustrating thing is it actually doesn't matter. Right, we've been on this. Oh, fire away, both of you. I'm interested in your opinion. No, it doesn't, Logan. So, if I go like this, and then let's put that in here, I've not changed any of the orientation. If I then go to evaluate and measure, and I am just taking it from this construction, what I can see. So the measurement here still resides as the same values. So what I mean is, it's a good spot. Don't get me wrong, it's a great spot, but sadly, it actually doesn't change anything. Yeah. What I'm going to do with this, guys, is I am going to do it to be continued, because it's caught me off guard as that. I mean, if there was a measurement of how poor a model is, this, yeah, I mean, let's face it, if this came in for CAD or anything like that, this would be an ultimate fail. Just because this is crazily bad, it's unbelievable. Yeah, you know, Damien, I could not agree more. It's something I've been pushing to them, but they kind of go, no, who needs a measurement tool? You go, well, if you want this to be useful for something like what we do, we need a measurement tool. Because if we had a measurement tool, we would not have this issue. I am going to take a look at this today, because it's a really interesting, fascinating problem, why that's failing the way it is. Once I find it, I'm going to continue and finish this off in tomorrow's session. If any of you are around, please log on. If any of you don't know what that time is, it's 1 till 3. It's 1 till 3. Log on. If you do solve this and you spot where this issue is coming from, please get in touch with me over Teams. I'm loving this. As bad as it is, I'm actually loving this, because it's not a direct solve. It is not a direct solution straight away. But what I'll do is I will save this. I'm going to save the model in progress so far. We're going to revisit this tomorrow, and what I want to do is close this off tomorrow, get this finished, get this running, because it'll give me some time to have a good look at it. Yes, Gareth, 1 to 3 on this, and we're going to fix this. And then what I wanted to do is do the final example that I wanted to show you all, and that is the gears. Gearbox is difficult. It's rock. Well, everything about this assignment is rock. I forgot you were there, Emma. Everything about this is rock. Now, what is the big thing about this assignment? Now, I didn't tell you this in class because I want you to really find this for yourself, but the truth of it is, in this assignment, is you don't know 100% what it is that you're going to find. You don't know 100% if you're going to find anything at all. 2 of these assignments, when you actually get to, well, 2, maybe 3, 2 of these, when you get to the conclusions of everything, you may come away and find there is nothing at all to find. But my fascinating thing with this is I want to see your academic rigorousness to look at something and say, I've considered it. It's a good job I'm not recording these comments. What I'm looking for you to do is to rigorously pull this one in bits, tear it to shreds, and kind of go, I've studied this, studied that, I've seen very little difference, very little promising input to suggest something would be better or worse. And what you've had before is you've had solve this equation, solve this answer, and with this, what I'm actually getting you to do is decide if something is worth doing or not. And yeah, it's normally the big reveal at the end of this assignment, but that is actually what I'm making you do. So when you move into it, I'm making you decide if something's going to be useful for it, if something's not. And when it comes to the engine, for example, everybody keeps to be looking straight away at the friction. I'm not looking for material loss. All it says is you need to consider that as a damping. What I'm actually looking at is other things. What you may find is slight variations. So for example, if you're looking at acceleration and then you're flipping the axes based on gravity, is that difference going to be there? Is it not? Aprilia claims it is. Ford claims that a lot of people are talking crap. What you're actually been involved with there is one of the biggest arguments or discussions, as they like to call it. One of the biggest discussions in industry to date is about configurations, V-twin configurations. Is it right? Is it wrong? What's the best way of doing it? What's not the best way of doing it? If anybody comes across any piston ring technology, yep, squeeze it in there. Piston ring technology, the slightest variations. My entire PhD was about 0.2 of a micron, and mine was suggesting it would give better performance. However, some have tested it and said it didn't. But then my argument is that they've not been setting it up right. So what I'm getting you to do is to do that. On this one in particular, this assignment, difficult. Positions, rigid transforms, you just can't escape them. They're horrible, they're brutal, and they just make you want to throw your PC out the window. I mean, I'm feeling like that right now. But with this, once you get this moving around, then all you need to do is make a little bit of a road, which we're going to do with this once I get these positions sorted. And all I'm asking you to do with that is create that critical damping, or half critical damping, as some would argue. So it's a really, really good argument with that, and it's interesting. The gearbox is a great one. Are you going to find anything? Are you not going to find anything? Is it gonna give you the straight answer straight away? Ducati sent it back, kept saying there's nothing wrong with it. However, the customer said that there was something wrong with it. So once you run through your analysis and you get to it, What are the final possible solutions that it could be? That's what I'm looking for. And on the robot arm, I want to know, when you get them spike values, you can't just say, I need a motor that does 100 million Newton meters. Because then you kind of go, what? What I actually need is something realistic. I need a good suggestion. These are the type of motors that you've been looking for with this type of performance. But I don't want you to just say they're the type of motors. I want you to at least prove or verify one joint. When it comes to the piston, from Gareth's comment on the stress transformations in the piston, now we're not considering the stress travelling through the piston because we've not equated for that to go into it. We can consider the vectors, so thrust face, return face, primary axis, first principal stress, second principal stress from them vectors that are occurring. We can consider them. Does it change under these configurations or does it not? Some of you, well not some of you, those of you on the piston may find this sneaky little thing called argon values which might actually start to play a role in this. But don't quote me on that, but you might find argon values start to reflect in this. I say reflect, only reflect, but it's a fascinating one. Right, so I've actually managed to, I was just about to say we've got books. I've actually just run over by half an hour, apologies for that. Yeah, I know, Gareth. I know this assignment is a sneaky devil. I've tried to write it like this because what I'm actually doing is this thing that's never happened to any of you. I am reciting on your professionalism. I want to know if you can actually come up with some types of conclusions. Your conclusions may be a little bit wrong, but the point is that you rigorously look at your particular model of choice. No, it doesn't. What this is about is discussing the assignment and really just opening that element up. Again, I am going to push the assignment by 10 days. A lot of people have had some problems. Let's face it, adjusting to this type of taught environment is really strange, really odd. I do intend, I think, running up a bit closer, if I can, I'm going to do some extra drop-in sessions. I'm going to run some extra bits just on fixing some of these things, doing bits of extra stuff. If anybody's interested in doing extra stuff outside of the assignment on this, let me know, because I do have Bill here as the robot head here, so I'm going to do a bit of microcontrollers in this as well, but that will be way outside of this assignment. So what I'm going to do is I want to revisit this because it's really irritating me. Again, if anybody comes up with, if anybody notes something that's gone wrong with it, and you know what it was that's gone wrong. Yeah, I know, planar joint's incredibly interesting. That planar joint allows for around an infinite plane, but you should be able to have revolution around that infinite plane, and that would in essence fix a few things. There's quite a few things that we could use on here that would fix it straight away, but I want to try and stay with the constructs that I've done here to figure out what it is that's gone wrong. Right, so the model I've done so far, the build I've done so far, and its configuration so far, I'm going to zip it together, upload it to YouTube, upload it to Blackboard, and today's part session I'm going to upload as well, so I need to encode it now and get it up to you. And then, like I said, I'm going to take a look at this off here and try and just see what's gone wrong with that construction, because there is something. Yeah, well, yeah, no, it's a good shout, Logan. What I'll do is I will zip it all together, everything together, and just upload it, and then you can take a good look for yourself. Because if you do spot something, please let me know, because it's an interesting one. And what I'll also do is, because what I'm going to do is actually bring in that spring damper, and then we're gonna finish this. We're gonna finish it and get it working, and that's why I'm really keen for it, because I actually do find it fascinating. This is my bag. I love this type of stuff. Let me just come back to where are we? There we are. So I'll save that. And is there any other questions before I sign this off? Yeah, well, that's what I want to do, Gareth. When we've been studying different things, so when we've looked at pistons, for example, I was pulling out different forces, or pulling out the torques from it, and all I was trying to do is I was pulling it from one joint. But with this, you can decide how much you're going to study from it. So you can study the gudgeon pin, you can study the piston, or you could study the revolutions that are occurring around the actual crank itself. Let me get rid of that. So basically, the reason that I've not got into massive levels of depths onto where to actually pull stuff out, sorry, 1 minute, where to actually pull stuff out, is I want you to see where to get these things from and then have a go at it. That's why I've left my channels open as much as possible, because if something's going wrong, if you're not sure about something, you're honestly welcome to ask me, and I can take a look at it and I can help you tune it to get the results that you're after. But what I need you to do is to decide what it is that you're going to look at. So that's why I've been pulling just individual bits out, and then we can elaborate on these things further. For the piston, for example, if you are interested, look at my notes, which I've done some verification for position, and it's just a typical way for doing verification of position and how you actually do it. So I did that on the single cylinder, so take a look at that. Right, so without further ado then, I will get off here and